Hello, everyone, and welcome back to series, or I guess version number 2 of the Python for Everyone series. So let's get started. We just talked about just the very standard data types. But now we're going to expand on that a little bit, talk about lists and dictionaries, as well as some other things like tuples, sets, and then after that, we'll move into the real good stuff where it's the loops and then conditionals. So let's not waste any more time and get started. First, we have the list itself. So as we remember, we can do text hashtag list. And now list, actually, they are ordered. So it matters when they are put in. And just a side note, Google Colab, you can use the stars for bullets. Lists are also mutable. So it means that they can be changed, deleted, etc. Lists allow for duplicates. So you can have the same value in the list multiple times. They are of dynamic size, which means they can be however big or however small, and they can range from small to big. And they, most importantly, accept different data types. So you can think of that as they can take int, string, they can take it all in the same list. Now, how do we make a list? Let's say example list will be our variable for the list. We're simply going to use these brackets, and anything in these brackets will be a list, or it indicates that it is list. So let's say hello is the first item in the list. Let's say goodbye is the second. And then let's also throw in a different data type. Let's say 23. Okay, so we have a list that's length of 3, and it's equal to the variable example list. Let's make that list. Now that we have this list, we can index into it to see what's actually in it. Now, the way indexing works in Python is in the list, 0 is going to indicate the first item, and then 1, 2, 3, so on. So let's get the first item. You just do brackets at the end, and then 0 for the index in the list. Okay, we get our first item. There we go, very good. Now what if we want the last item? Just simply do example list. And we really have two ways we can do it. We can either do 2, or if let's say the list was really, really long and we don't want to count each number, we can also just do -1. That just indicates the last item. There we go. Now what if we wanted both the first and the second? We can do example list, brackets again, say 1, or really 0 is the start, and it's through 2. All right, we got hello and goodbye. So really how this is working is it's giving the 0th in the first item, not really including this 2. So it's 0 and 1. There we go, first 2 items. Now, moving on even more, we can insert into the list or add new items, let's say through append. All we're going to do is say example list dot append, let's say new item. Now let's call example list. What do you think this is going to do? Is it going to give the original list, or is it going to give the updated list with the appended item? All right, it gives us the appended list. So when you're using list in general, it's going to actually edit the list itself. We don't have to do something like we did earlier, where it was example list equals that. This is because lists are mutable, whereas strings, ints, floats are not. We can actually change it, and we don't have to redeclare it. All right, let's move on. What if we wanted to insert? I don't know, let's say we wanted to insert between hello and goodbye. All we would do, let's say example list, we would just do dot insert. And then what we're going to pass is where to insert it, basically the index, and what to insert. So we want to go between hello and goodbye. So we really want it to be in that first position because it'd be 0 and then 1. So we'll say 1, and let's just call that inserted item. And let's call example list. All right, we now have this inserted item in there, right, at position 1. Now what if we, I don't know, let's say we wanted to remove this and we didn't want to have it. Just do example list dot remove, and let's say inserted item. All right, it removes it from the list. Let's get our list. There we go. Now, what if we had duplicates, or what if we wanted to count how many of a certain item were in the list? Let's first append onto the list another new item, and let's say it's 23. So let's do dot append, and let's do 23 again. We can also just call it to get our list. All right, so now we have two 23s. What if we wanted to count that? All we would do is example list dot count 23. All right, we have two items equal to 23. What if we did that on hello? 1. Okay, that makes plenty of sense, I think. Enough to move on to the next, which is tuples. We're not going to dive super deep into tuples and sets, but we can at least talk about them. So let's put them in the same category. And let's do a subcategory for tuples and make some notes. So one note is that these are ordered, just like lists are. The way you put them in is the way that you see them. They are immutable, meaning that they cannot be changed. So we can't do any of this remove, append, insert. Can't do any of that because they cannot be edited. As soon as they are declared, that is it. They do allow for duplicates. So that's fine to have multiple items that are the same. And they also accept different data types. Now, how do we make a tuple? Just like a list, but instead of using brackets, we will use parentheses. Let's just use what they have. If they ever want to code for you and it seems correct, you can just hit tab. But when you're learning, it's best to keep typing it out. All right, now we have our tuple. What about indexing? Same exact way as a list. 0. All right, we got the first item. Simple enough. You can also just do arrange like we did earlier. Basically the same kind of things you can do with a list, but you can't do any of these you can't change the variables or append or delete or any of that. It's just once it's set, it's set. So you can think of this as more of a things that are constants and don't really lists that are constants and don't change. Might be roles in the game if the roles in the game don't change. Now what about sets? Sets are unordered. So they're really just a pile or a random collection of variables. You can think of it as the order doesn't matter when they are put or when they were ever put in or out. An important thing to note is they are mutable, so they can be changed. You can do all those other append and methods just like that, or add. What else? They very importantly do not allow for duplicates. This is like if you had usernames, you would want to put your usernames in a set because they don't allow for duplicates. You can only have one item for each thing. And they also, of course, accept different data types. Now to actually make a set, just as we've basically done, but using these brackets. Now, we did use brackets earlier, but that was in an F string. So these are just kind of brackets on their own. Let's say that we had, I don't know, hello, goodbye, and then another. All right, there we go. Now let's test out what if we had, say, example set 2. Let's say we had a repeat. That's also okay. Oh, yeah, I thought the duplicates weren't allowed, but maybe you guys can check me on that, or I'll make a comment in the video later. Now for adding elements, simply going to do example set dot add, let's say another set item. Let's call it example set. There we go. We added another set item, and notice how the list or the order does not matter. We just put it in there and it does it for us. Basically, it's doing it by alphabetical because it doesn't matter. Now let's say we wanted to remove what we just added. Just simply example set dot remove, and let's say hello. Oops. Notice how there's an error because we tried to pass a variable. It doesn't exist. It was supposed to be a string. All right, there we go. We can now see that it was removed. All right, that's about it we're going to talk about for sets right now. I don't really use sets and tuples too much. It's probably best to in certain circumstances, but for what we're really going to be doing, and especially data analysis and stuff like that, we won't have to work with them too much. We'll work with dictionaries most, which is what we're going to talk about now. Dictionaries. What's important about them is that they have an inserted order. Well, they're really not that important at the end of the day. But as you put them in is how you're going to see them. They are mutable, meaning they can be changed. Now you may ask, okay, what's going to be changed? Dictionaries, they're really just a set of key value pairs. So similar to what we've done earlier, where we just say an example is equal to a string, it's really almost like that. It's a key and a value. We'll discuss that now as we actually start doing tuple, or we actually start doing dictionaries. Let's say example dictionary, set it equal to a dictionary. Okay, oh, you may say, oh, we're using brackets. Isn't this a set? No, the key difference is now that instead of just putting values like hello, goodbye, and so on, we're going to have key value pairs. Now, how do we do this? The left item is going to be your key. So let's call it key 1. And it's going to be usually in a string, but you may have it equal to variables. But for now, just stick to strings for them. And now what comes after the colon is its value. So let's just say value 1. All right, that's our first item in the dictionary. Let's add another item, just simply comma between there, and just do key 2 equals value 2. All right. Now that we have our dictionary, you may ask about the repeats. There cannot be repeat keys, but there can be repeat values. So we could not do something like this. Let's say another key 1, another. Now, while it will not give you an error, you're going to have problems later if you do it like this, because you're not going to be able to access what you want for key 1 because they're equal to 2 different things. Now, what about actually accessing the dictionary? We'll just run this again so we have the example. Accessing it, very similar to the indexing, but we're passing in actual names for these indexes. Example, dict, just use brackets like we did earlier. We're going to pass in key 1. And what's going to be returned is value 1. All right, there you go. You can see how that works. What if we wanted to add on to this dictionary? We would do something just like this. Example, dict, bracket. Inside of there, instead, we're going to say our new key name. So let's call it key 3. And now we're going to set its value by doing equals to value 3. Now notice the difference. You're going to be using the colons when you're actually in the dictionary, but when you're setting values, you're using the equals. So really, instantiation, you use colons. Adding values or changing values, you're going to do equals. Let's get example 3. Or oops, not example 3, example dict. All right, we added that in. What if we wanted to change something? Just as simple as this. Say we want to change key 1. Pass in which key we're changing and what its new value is going to be. Now, if we access our dictionary at key 1, you can see it's equal to that new value, just like we said. Now, to remove things from the dictionary, it's a little different, but pretty simple. Just you say del for delete, example dict, and then the key of which you're going to delete. Let's say key 3. And let's look at that. All right, key 3 was removed. There you go. That's pretty much it for dictionaries. Dictionaries are really something that you'll make use of later on for most of what you do, and it's really helpful for organization, especially with the accepting multiple data types. I'll give an example of that now. Let's say example dict2 equals the dictionary. If you want more structure to your dictionary, we can do it like this. Let's say hello, and then let's say, I don't know, something. All right, this key is equal to the string something. Now let's say an example list in here. We can actually set it equal to a list itself. Etc. Get the point of how that works. Still commas between. And then lastly, what if we wanted a dict in a dict? Which is really, you can think of it as an outline, really, if you start doing this. That's how I think of it. We say dict in dict. It's going to be, let's just use key 1, value 1. I don't know. You don't have to say key. This could really be anything. It's just an example. All right, now that we have this big dictionary, what about indexing into it? Because there's a dictionary in a dictionary and also a list in a list. Almost identical to what we were doing, but think of it in levels. Okay, first level is hello, example list, and dict and dict. Those are basically your first level keys. Okay, let's say we want to get into this list. Say example list. We can return that for now. Oops, I have a typo. Oh, example dict2. Because it's not in example dict. All right, we got the list return. What if we wanted to get a specific item from that list? You just do this, we're on that level, the example list level. Now that we have that, we can index into it. Let's give the second item or the first index. All right, we get B, just as we expected. Now that you have all those data types, lists, dictionaries, we can move into conditionals and loops, which is where we really start using the code and where you're going to do most of your learning as we go on. Let's say conditionals and loops. And we can start out with conditionals. These are exactly what the word describes, conditionals. It's only doing things under circumstances. Like, if this happens, then do this. If this happens, then do this. Let's do an example. These are called if statements. If, I don't know, or you can say true. This easiest, most simple example. If true, just simply print it is true. And notice how there's indents under there. just means that it's related to this if statement. Now, what if that wasn't the case? We can just say print it is not true. Let's run that. It is true. So it just says it is true. It's running what's in here because it was true. Now, to really use them, you should be having it equal, your Boolean equal to a value that can be changed over time. Say conditional 1 equals true. And we can say, instead of if true, we say if conditional 1. You can say print it is true. And then just, you don't have to say the else statement. We can just do this. Does the same thing because it's basically saying if true, do this. That makes total sense. It's just as straightforward as can be. Now, what if we had not an if else? What if there was several things involved? And what if we didn't want our conditional 1 to be equal to true? Let's say we wanted names in the database or that. Let's say name 1 equals my name. Name 2 equals, let's just say Anthony. And name 3 equals Mike. Now let's also give, let's say that there was a repeat price. 4 equals price. All right, now we have all these variables. And just as we stringed on if statements earlier, or not if statements, but Booleans, you can also string those Booleans while doing your if statements. So let's say if name 1 equals name 2. And name 1 equals name 3. Just say print it was true. Else it was not true. All right, we can see that since this is false, it's going to be the else statement that goes. Think of it again as we did earlier. These are essentially in parentheses. You can even do parentheses if you want. Might be more useful and allow you to see it better. It's saying if, and then this entire statement. You got to break down the statement. Name 1 equals name 2. Okay, that's false. And name 1 is equivalent to name 3. Okay, that's also false. We know that if there's any falses in an and statement, it's false. So we know it's not false, or we know that this is not true. So it's if false, really, which is not the case. So it's the else. It's only going to run if the if statement is true, or if the final statement is equal to true. Now, what if we wanted to do multiple checks? If name 1 equals name 2, we can say print name 1 is equal to name 2. Let's get rid of this. What if we wanted to also check, but not do it in one single line? Elif name 1 equals name 3. We can just say print. So if that's true, this is what's going to run. Name 1 is equal to name 3. Okay, we know that's also false, so that's not going to be run, but it's just an example because you could have these name variables change later on or something else you're using. Let's do another elif. But this time, we want it to be true just for an example case to show the elif being triggered. We can do the same as we did earlier. Name 1, but instead of equal to, we do the not equal to name 2. So the whole expression's going to be true. So it's really, what's going to be triggered is elif true. Okay, so now that you know that this is going to be run. Print name is not equal to name 2. We don't even, all right, with elifs, you do need an else, actually. That's one thing to remember. Just say, none were true. All right, we see that this elif's triggered because this is the one that's equated to true first. And we can keep going on with these if statements, but we really have already broken down to what they can do, and later on all you're going to be doing is expanding them, but you're using the same if, elif comments, and then inputting those true values all in. So we've already covered how to do everything in order to make complex conditional statements. When programming in Python, just keep it simple wherever you can. When we're doing our big if statements, to keep it manageable, let's just think about if it's going to be true or false. Okay, to do that, we need to know how to break down those statements. So make sure that you break it down correctly using the ands and ors if they're there. And you can see how it can seem complicated from afar, but if you break it down into each type, it becomes much simpler. Now, really, these conditionals and lists that we just talked about and dictionaries lead into using loops, so we can actually look at them. Let's say loops. And there's two main types of loops. There's the for loop, and there is the while loop. Now, loops essentially just keeps doing the same thing over and over again while a statement's true. Let's do a for loop. Let's say we have an example list equals 1, 2, 3, 4, 5. We can just say for item in sample list, print that item. Now here, where we said item, this could be anything. This could be for X an example list, for Y an example list, but you can just have it be equal to item to have it be more simple. And on the first iteration of the loop, item is going to be 1. So what's going to be printed out first? 1. Now what's really happening now is the index, instead of being at index 0, it's going to be at index 1. And now item is going to be equal to 2. And item is also going to be equal to 2 here. Let's see that. All right, you can see how it goes through the whole entire list for each item in it and gets them all separately. Let's show a better use case of that. Let's say example list equals, let's just say it was a bunch of name 1, name 2, and name 3. We can use our f strings for use here. Let's say for name in sample list. We want to print f hello, and whatever the current value for name is going through here, name. All right, hello name 1. So you can see how the repetition, it's really for automation, and it takes a lot of the hard coding away. Instead of having to write hello name 1, hello name 2, and printing all that, you can do it all at once. Now, what else can we do with these for loops? We can also use ranges if we didn't have a list. To use range, you would just do range something like 10. You can show it's a range of numbers from 0 to 10. That's what it is. Now for I in range 10. All this is going to do is it's really just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is what it'll print, because that's what in is in that range. There you go. So if you wanted to have something done 10 times, you would just say for I in range 10. So you wanted it the code only executed 5 times. Okay, you just say 5. And of course, you're going to have the 0, 1, 2, 3, 4. What if we didn't want to include 0? We say if I equals 0, continue. So it means, continue just means get out of here, go back to whatever the next I would be. You're not breaking out of it. You're just not executing any code below the continue, and you're changing to the next I value. There you go. It doesn't print out because the continues run. What if we want it to stop when it gets somewhere? We can use break. If I equals 5, or 4 really. Break. And we can also say a message also. Print. Say an F string again. You have reached the end of the list. The last value is I. There we go. Breaks out, and that completely breaks us out of this loop. Basically, as if we're on a whole brand new line of code. You can see when it was executed. What if we had a dictionary again? Let's just copy one of our old dictionaries. All right, let's copy this. There we go, we have that. We can say for, it's the same exact thing. For item in example dict. Now, item is really equal to the key in the dictionary. So if we want to actually print out, not the key, but the item itself, we would just do example dict item, just as a normal dictionary would. You can see it prints what the values are equal to. Now, what if we also wanted to see the key? Very simple. It's literally the same thing. But instead of this, okay, let's change this to an F string. Wrap the anything Pythonic, brackets. We can say the value is, okay, this is literally the same thing we done earlier, but changing it to an F string, adding some content. Now we want to get at the key also. The current key is literally just item instead. Don't index into the dictionary, just say item. There we go. Now we're getting both the key and the value. And that's it for now for for loops. As I said, we're going to be working with these more and more, and I'm going to keep explaining them as we do actual code and start making our own programs. You learn a lot more in Python by just making programs and using what you know, and if it doesn't work, you figure out why it didn't work. And it's often just a reminder to the basic types and other errors, and from those errors, you continue learning on. Now for while loops, they work pretty similar, but they're going to keep going on and on and on while something's true. So as I said earlier, we can set a Boolean. We can have an example Boolean equals to true. And we can say while example bool. So it's essentially saying while true, print it is true. Okay, now what would happen if we executed this? It would just keep printing because it would get stuck in here, and we do not want that to happen. That's how you can cause crashes, errors like that. So it's always good to, especially when you're testing, limit it using a break statement. So if we did this, it would only do it once. Now, what if we want to do it more than a couple times? Let's just say our counter is equal to 0. We can do, after we print, we change the counter plus equals 1. So now counter is 1 essentially. And if the counter equals 5, then we can either break, or we can say example bool equals false. So when it goes back, it's going to say, well, false, and it's going to say, oh, we're done with this loop, and it's going to break out of it. Almost like a break statement, really. There we go. It does it 5 times, just as we wanted.